Hello everyone, welcome back to the channel. I am the EE Guru, and today we'll be working on current division example problems. If you haven't seen my previous video on current division, I recommend you watch that video first and then come back to this video and we can work on the example problems. Also, I recommend as we're working on the example problems, pause the video and try to solve the problems on your own first, and then we can work on it together. And that is meant to help you gain confidence in solving these type of problems on your own. So let's dive right on into it. Looking at example problem number 1, we have two unknown current, I1 and I2. We know the value for IS, which is the current source. It's 10 amps. So what we're going to do is we're going to write down the equation, the current division equation for I1 and I2, and then we're going to plug in values into the equation and evaluate the equation for I1 and I2. So we are going to try to solve for I1 first. So we'll write down the equation for I1, and I1 is equal to IS multiplied by R2 divided by R1 plus R2. We know our value for IS, which is 10 amps. We know our resistance R2, which is 12 ohms. We know our R1 value, which is 8 ohms. So we're just going to plug in those values and get our value for I1. So when we evaluate this right here, we get 120 over 20, and that's equal to 6 amps. We get I1 is equal to 6 amps. So now we're going to do the same for I2. We're going to write down the equation. I2 is equal to IS multiplied by R1 divided by R1 plus R2. And then we're going to plug in the values for the different variables like resistance and IS. So I2 is equal to 10 multiplied by 8 ohms divided by 8 plus 12. And we get that I2 is equal to 80 divided by 20, which is equal to 4 amps. We get that I2 is equal to 4 amps and I1 is equal to 6 amps. And this makes sense because if you've seen my previous video on Kirchhoff's current law, we know that the sum of current going into the node is equal to the sum of current coming out of the node. So we know that if 10 amps is going into the node and the current that is coming out of the node is I1 and I2, we know that I1 and I2 must sum up to 10 amps. And this looks about right. I1 is 6 amps and I2 is 4 amps, and that sums up to 10 amps. So that's the way you can kind of check your answer to make sure it's correct. So let's move on to the second example problem. So for the second example problem, we'll do the same thing. I recommend you pause the video and try to solve this problem on your own before we work on it together. So let's just dive right on into it. So do the same thing. I1 is equal to IR. This time is IR instead of IS because the variable is different. But the equation is still the same. It's just we renamed the variable. So I1 is equal to IR times R2 divided by R1 plus R2. So we're going to plug in our values. So this is IR. So we know the value for IR, which is 4 amps, multiplied by R2. R2 is 3 ohms divided by R1, which is 2 ohms plus 3 ohms. Okay, we get that I1 is equal to 12 divided by 5 amps. And let me bring out the calculator real quick and just do 12 divided by 5, and I get that is equal to 2.4 amps. So I1 is equal to 2.4 amps. Okay, let's solve for I2. We do the same thing. We write our equation down, the current division equation for I2. And then we plug in the values and evaluate the equation. So IR is equal to 4 amps. R1 is equal to 2 ohms. And R2 is equal to 3 ohms. And then we just evaluate the equation and we get that I2 is equal to 8 divided by 5. And let me bring out the calculator. 8 divided by 5. And we get 1.6 amps. So I2 is equal to 1.6 amps. Let's see if this makes sense. We know that the current going into the node is 4 amps. And the current coming out of the node is I1 and I2. Do I1 and I2 sum up to 4 amps? So 1.4 plus 1.6 does equal 4 amps. So yes, it makes sense, and we verified that this is the correct answer. So the third problem is a challenge problem that I want you guys to try to solve on your own. And basically what you have to do is try to solve for IS and I1. We are given I2. And this is a little more tricky because previously I always gave you the value for IS. Now it's not given. Now you have to solve for it. But you can still solve for all these unknown currents by using the same equation. You might have to change the equation around and do some algebra, but you can still solve for IS and I1 using the same equation. Also, if you're feeling brave and confident about your answer, write the answer down below in the comment section and I'll reply to the first correct answer that I see. So that's the video. If you liked the video, hit the like button and don't forget to subscribe. And I'll see you guys in the next video.